everyone, welcome to this virtual world of learning. So let's start with the topic, that is numerical problems related to mole concept. Let's start. The question is, find the number of each type of atoms present in 0.15 mole of water. Find the number of each type of atoms present in 0.5 mole of water. Here each type means the atoms which are present in water molecule. For 1 mole of water, it has 2 hydrogen atoms and 1 oxygen. In 1 molecule of water, there are 2 moles of hydrogen atom and 1 mole of oxygen. Here we have to calculate the number of atoms in 0.15 moles of water. First of all, we have to calculate number of hydrogen atoms, then we have to calculate the number of oxygen atoms. For this, we know that 1 mole of water contains 2 moles of hydrogen. 2 moles of hydrogen atoms. 2 moles means 2 into 6.022 into 10 raised to power 23 hydrogen atom. As we know that 1 mole is equal to Avogadro number, and the value of Avogadro number is 6.022 into 10 raised to power 23. Therefore, 1 mole of 1 mole of water molecule contains 2 into 6.022 into 10 raised to power 23 hydrogen atoms, and we have to calculate in 0.15 mole. So put here, in 0.15 mole of water, the number of hydrogen atoms are 0.15 into 2 into 6.022 into 10 raised to power 23. That is 30 into 6, 18.066 into 10 raised to power 24 divided by 100, or 18.066 into 10 raised to power 22 hydrogen atoms. It means in 0.15 moles of water, there are 18.066 into 10 raised to power 22 hydrogen atoms. In this question also we have to calculate oxygen atom. So for oxygen atom, put the same equation for the oxygen. One mole of water molecule contains 1 mole of 6.022 into 10 raised to power 23 oxygen. As 1 mole is equal to Avogadro number, or 1 mole is equal to 6.022 into 10 raised to power 23 particles. In this question we have to calculate the number of particles or number of atoms. So we put here Avogadro number. Now in 0.15 mole of water, number of oxygen atoms are 0.15 into 6.022 into 10 raised to power 23 divided by 100. It comes out to be, when we multiply it by 15, it comes out to be into 10 raised to power 23 oxygen atoms. Hence, in 0.15 moles of water, there are 18.066 into 10 raised to power 22 hydrogen atoms and 90.330 into 10 raised to power 21 oxygen atoms. Thank you. Now, the next numerical problem related to mole concept is calculate the mass of carbon monoxide that has same number of molecules present in 2.2 grams of carbon dioxide. The question is, calculate the mass of carbon monoxide that has same number of molecules present in 2.2 grams of carbon dioxide. Means, first of all, we have to calculate the number of molecules present in 2.2 grams of carbon dioxide. First of all, we have to find the number of molecules present in 2.2 grams of carbon dioxide. So first of all, we have to calculate the number of molecules. According to mole concept, we know that 1 mole is equal to Avogadro number, or equal to 6.022 into 10 raised to power 23. Also, 1 mole is equal to molecular mass. So, first of all, we have to calculate the molecular mass of carbon dioxide, that is 44 grams. Now, in 44 grams of carbon dioxide, the number of molecules present is equal to Avogadro number, as 1 mole of the substance always contains the number of particles equal to Avogadro's number, that is 6.022 into 10 raised to power 23. As we have to calculate it 2.2 gram, so put the equation in 1 gram, 6.022 into 10 raised to power 23 divided by 44, and we have to calculate in 2.2 grams of carbon dioxide equal to 6.022 into 10 raised to power 23 divided by 44 multiplied by 2.2. This comes out to be 3.011 into 10 raised to power 22 molecules. As these are the molecules present in carbon dioxide, and in the question it is given that the same number of molecules are present in carbon monoxide. If same number of molecules are present in carbon monoxide, then what is the mass of carbon monoxide? So calculate. In second part we have to calculate the mass, so we put mass on right side and number of particles on the left side, because in second part we have to calculate the mass of carbon monoxide. So put the equation 6.022 into 10 raised to power 23 molecules has mass equal to, the mass of carbon monoxide is 12 plus 16, that is 28 gram. It means 1 Avogadro particles or 6.022 into 10 raised to power 23 molecules of carbon monoxide has mass equal to its molecular mass, that is 28 grams. One molecule has mass equal to 28 divided by 6.022 into 10 raised to power 23, and we have to calculate in 3.011 into 10 raised to power 22 molecule. So put here 3.011 into 10 raised to power 22 molecules of carbon monoxide has mass, that is 28 divided by 6.022 into 10 raised to power 23 multiply by 3.011 into 10 raised to power 22. It comes out to be 14 into 10 raised to power minus 1 or 1.4 grams. It means the mass of carbon monoxide that has the same number of molecules as in 2.2 grams of carbon dioxide is 1.4 grams. This is another type of the numericals problems related to mole concept. I hope this question is clear to all of you. Now we will solve the next type of question based upon mole concept, and the question is, find the volume in oxygen gas having same particles as present in 2.3 gram of sodium. The question is, you have to find the volume in oxygen gas if the oxygen gas has same particles as present in 2.3 gram of sodium. This question is done in two parts. In first part, we have to calculate the number of particles present in sodium. Then from that particles, we have to calculate the volume of oxygen. First of all, we have to write the formula of mole, that is 1 mole equal to molecular mass or molar mass equal to 6.022 into 10 raised to power 23, that is equal to 22.4 liters. This is the basic concept of mole. By using this concept, we have to solve this question. In this question, first of all, we have to find the number of particles in 2.3 gram of sodium. So solve this question. See the first part, in which we have to find the number of particles. In this question, or in this statement we have to find the number of particles and mass is given to you. So use these two terms, that is molar mass and number of particles. In this we have to find the number of particles. So put number of particles on right hand side and mass on the left hand side. As the molar mass of sodium is 23, it means 23 gram of sodium has particles equal to Avogadro number. This is given to you. Molar mass of sodium equal to Avogadro number 6.022 into 10 raised to power 23. So the 1 gram of sodium is equal to 6.022 into 10 raised to power 23 upon 23, and you have to find in 2.3 gram of sodium. So put here 2.3 gram. In 2.3 gram of sodium, the number of particles are 6.022 into 10 raised to power 23 divided by 23 multiply by 2.3. It comes out to be 6.022 into 10 raised to power 22 particles. These number of particles are present in 2.3 gram of sodium. If these particles are present in oxygen gas, then what is the volume of oxygen? In the second part, it is given to you if the same number of particles of sodium are present in oxygen, then what is the volume of the oxygen? So in second part, we use these number of particles for calculation of volume of oxygen gas. So in second part, we use number of particles and volume. So in this question or the second part, we have to calculate the volume. So put volume on the right hand side and number of particles on the left hand side. From this definition, we know that Avogadro number of any gas has volume equal to 22.4 liters. So put here 6.022 into 10 raised to power 23 particles of oxygen has volume 22.4 liter, and one particle of oxygen 22.4 divided by 6.022 into 10 raised to power 23, and you have to calculate in this much particle of oxygen. Put here 6.022 into 10 raised to power 22 particles of oxygen. It comes out to be 22.4 divided by 6.022 into 10 raised to power 23 multiply by 6.022 into 10 raised to power 22. When you solve this, it comes out to be 2.24 liter. This is the volume of the oxygen gas having particles equal to 2.3 gram of sodium. In this type of question, start from the last line or last part and come to the first part after solving the second part.